differentiate both sides. And when I differentiate a function to a power, I get 2y dy over dx. Here, I have to apply the product rule, keeping in mind I can keep the -3 outside. So this is 4 x to the third sine y plus x to the fourth sine prime is cosine y times the inner function prime, which is dy over dx, equals 66x. At this point, I have to be careful because the variable is here, but as well in here. But first, I have to distribute -3. So then,
I have a question.
Yes?
Would it not also be next to the sign?
So I have to distribute -3 here. This is a product.
But dy
Only
over
once.
dx.
It's a here.
Mm-hmm.
No, I'm differentiating the first function. I'm not differentiating the second function. The product rule says first function prime times the second one. Don't touch it. Just copy it. Don't do anything.
So we don't do dy over dx in that case.
No. So f times g prime is f prime times g plus f g prime. So this is f,
changing it from y to
and
dy
this
over
is
dx
g.
when that part is being differentiated, since that
I
section
can't.
is not being
I
differentiated.
can't. Yeah.
Yes. Okay.
It's not possible. I'm differentiating for x to the fourth.
Got it. Okay. Thank you.
Thank you. Very good. So then I'm continuing, and I think this is my page 5. So then we have 2y dy over dx equals, oh, not equals, sorry. I didn't mean to write equals, of course. Minus, I'm distributing first. So minus 12 x to the third times sine y minus 3 x to the fourth cosine y dy over dx equals 66x. Now I will factor dy over dx, so I have 2y minus 3x to the fourth cosine y dy over dx. This term will be joined by this term with positive 12x to the third sine y. So therefore, dy over dx equals all this over all this. Any questions? Any questions, please? Any questions?
Can you go back through it again, please? I don't think I get it.
From here, you mean, or which part? You mean from the beginning or any particular step? Evelyn, you're muted. Were you asking something or not? Evelyn?
I keep on unmuting, but I'm not looking. It's not unmuted. Okay. Right from the beginning.
Okay.
Thank you.
So function to the second power, the rule is 2 times y to 2 minus 1 times the inner function prime. Is this okay?
Yes, so far. Thank you.
So then I keep -3 outside. I differentiate x to the fourth, and I copy the second function. Plus, I copy the first function, and I differentiate the second function. Sine of a function prime is cosine y times the inner function prime.
Okay.
And when I differentiate this side, is 66x.
Okay, go ahead. I'm following. Thanks.
And now from here on, it's just algebra. I have to distribute -3 to these two terms. So I have 2y dy over dx, 3 times 4, -3 times 4, -12x cubed sine y. And then -3 times this, -3x to the fourth cosine y dy over dx equals 66x. Is that okay?
So far, thanks.
Then I factor out dy over dx because I have to. These terms are not like terms. I have to factor out this. So then I have 2y and then this with -3x to the fourth cosine. And this term goes to the other side and it becomes positive. At this point, this is this over this.
Okay.
Is this
Okay, that's all you know.
Is it better?
Much better. Thank you.
Thank you. Again, just seeing it, it's okay. But what I would do if I were a student in this class, I would redo this on my own 3 times. Because that's the only way I can build my confidence. Okay, so let's go back to the book. Let's choose any other problem. We worked on 53. Anything else you would like to see from 49 through 56? We are practicing logarithmic differentiation. Which one we would like to continue with?
56, please.
Very good. So 56, this is not a good color. Okay, 56. So y equals natural log x, everything to power cosine x. Do not be afraid of these. If you follow the steps, if you understand the steps and practice them, you will never have any difficulty here. First step is this. Step 2 is apply log. So I have natural log y equals natural log of natural log x to power cosine x. What is the next step at this point? What did we say we had to do next?
Bring the cosine down.
Yes, we are applying a property of the log. That's why we apply log, right? Natural log y equals cosine x multiplied by natural log of natural log x. Perfect. Now, yes, we have to differentiate implicitly. So let's differentiate the left-hand side. I'm going to put a dot under the function. Y is not a variable. Y is the function of x, as you see it here. A function of x. So what do we do? How do we differentiate the left-hand side?
1 over.
Yes, awesome.
Over y dy dx.
Yes, awesome. Thank you so much. Now careful because this is the product rule. I differentiate the first function. What do I get?
Negative sign.
Awesome. Times natural log of natural log x. Plus, I copy the first function. But now carefully I have to differentiate this. What do I get when I differentiate natural log of natural log?
Is that 1 over
1
natural log x
Times the inner function prime.
1 over natural log x.
The inner
Oh,
function
sorry. 1.
over the inner function prime. What is natural log x prime?
Over x.
That's it. Awesome. Great job. Thank you. Awesome. Not done because I have to solve for dy over dx. It's not yet solved for dy over dx. So how do I solve for dy over dx? What do I need to do to both sides to solve for dy over dx?
Divide by 1 over y.
Multiply. Because it's in the
Multiply by
denominator.
1.
Yes.
Let's multiply. Sorry.
Good.
Yeah.
Which in this case is natural log x to the power of cosine x.
Very good. And now let's try and simplify a little bit or condense a little bit. So I have negative sine x times natural log of natural log x plus, I'm not going to write it here because it will crash with the page number. So I have cosine x over x tangent x. Natural log x. Of course, not tangent x. That's it. You're done. How do we feel about logarithmic differentiation? How do we feel about logarithmic differentiation?
Can we do another example?
Absolutely.
But in a moment,
Absolutely. And then I would like to choose from these examples. Because I don't think we practiced, but I think we should do at least one more. And then we can continue with 3.7. That's why I was making sure in the book that we touch up on different types. Okay, ready? Oh, I said ready, but I changed the screen. Yes, which one? We want to look at. Which one?
Did we already do 52?
No, we did not. You want to do 52?
Yeah, the square root. I want to try that.
Awesome. So 52, y equals the square root of x raised to power x. Perfect. So the step is natural log equals natural log of the square root of x to power x. Of course, we discussed that, natural log of y, x, natural log of the square root of x. Yes, we have to differentiate. Can anyone differentiate the left-hand side for us?
1 over y
Sure.
times dy dx.
Brilliant, thank you very much. Now this is a product. The first function prime is that's how my cheap markers are drying out. My students don't tell me what to write.
Line square root x.
Yes, so x prime is 1, so natural log of the square root of x plus the first function times. We are differentiating natural log of the square root of x. So first we differentiate natural log. What is it?
1 over x.
Yes, but in this case is the square root of x. Awesome. Now we are differentiating the square root of x.
That's 1 over square root of 2 times square root x.
That's it.
Yeah.
Perfect. So now when I multiply these two, I get 2x. And I'll have to simplify here. So let's write one more step. dy over dx equals natural log of the square root of x. Again, this is x divided by 2x. So this is plus 1/2. All this is 1/2. Because these simplify. The square root of x is x, simplified with the x at the top. Now, final step, I have dy over dx. What do? I need to solve for dy over dx.
I see multiply y on both sides.
Yes.
And substitute.
Already replace or substitute y by the square root of x raised to power x. Perfect. Okay, good pick. So now let's go to a couple of problems with the inverse trig functions. We had some. Let's work on one more. I'm only interested in sine inverse, cosine inverse, and tangent inverse. Let's work on one more. I think it's my turn. I choose 69 or 71? Which one? It's my turn, but I still ask you.
71.
71 it is. Very good. 71, so we have f. I'm going to replace it by x. So 71, it's e to arc sine x squared. Perfect. I noticed something in your homework. It's not the same to write sine x squared with sine x squared. These are not the same. Be careful. Solutions are posted for all written homework, so almost homework assignments. So in order to differentiate this, I realize that this is e to a function. E to a function. E to a function prime is e to that function times that function prime. So outer, inner. So when I differentiate arc sine, I get 1 over the square root of 1 minus this quantity squared, which is x to the 4th. Now times the inner function prime. I can condense it a little bit. I would write 2x e to arc sine x squared, everything divided by the square root of 1 minus x to the 4th. And this is it. Any questions on this? Any questions? Okay, so let's move on to 3.7. So I remind you that we have 3.7 left, 3.9, and 3.10. In 3.7, we're going to look at rates of change in social sciences, or in different sciences. It's natural and social sciences, different fields. Okay, so the major one that we look at is basically in physics, and everything else for chemistry, biology, and so on and so forth, they will be discussed in the appropriate classes. So we're going to go to and look at simple situations